Okay, so today we're going to solve exponential equations, and I want you to pay close attention. We're going to solve two different kinds of equations here. So the first type of equation I want to show you has an exponent on both sides. So here I have a to the x, here I have 2 to the x plus 6. So if you look at all four of these, they're all similar. I have exponents on both sides of the equal sign. Okay, so that's one type we're going to solve. The second type we're going to solve is where an exponent is only on one side. So here's an exponent, there's not an exponent, okay? All of these you can see have an exponent on one side but not on the other side. Okay, so let's start with exponents on both sides. So first of all, an exponential equation is an equation that has a variable as an exponent. So something like this, 2 to the x equals 8. The variable is in the exponent. So how do we solve this? We're going to express both sides of the equation in terms of the same base. So what does that mean? If you look at number 1 right now, we have a base of 8 and a base of 2. Those are not the same. So I want to try to make them the same. So when I look at my bases, here I wrote out some of our simple bases. So here I have 2 on this side. So I'm looking at all of these with a base of 2, and I see that 2 to the third equals 8. So what I want to do is I want to change this 8 to 2 to the third power. So what I'm going to do is rewrite this. I have 2 to the third. I'm going to leave that x equals 2 to the x plus 6. So then it says if the bases are equal, then the exponents are equal. So if you remember when we did our log equation, so we had something like log x plus 2 equals log 2 16. And we said, oh, well, if the bases are the same for the logs, we can cross out the logs and we can go x plus 2 equals 16. Okay, similar situation here. Instead of logs though, I have exponents. So I'm going to cross out the 2's and set the exponents equal to each other. So here I have 3 times x, so I'm just going to write 3x, equals, and then here I have x plus 6. And now I have just a regular algebraic equation I can solve. So I'm going to subtract x, 2x equals 6, divide by 2, and x equals 3. So make the bases the same, set the exponents equal to each other. Okay, let's try number 2. So I have a base of 9 and a base of 27. So I say, okay, well, let's see, can 9 to any power equal 27? 9 to the first is 9. 9 to the second is 81. So I can't make anything a 27. So instead, on this one, we're going to actually change both sides of the equation. So a lot of you already know that 3 squared is 9. So here I have 3 squared is 9. But 3 to the third is 27. So I'm going to change both sides of this equation. So this 9 is going to become 3 squared. This 27 is going to become 3 cubed. So I change the 9 to 3 squared. I still leave that 2x equals. And I change the 27 to 3 cubed. And I leave the x plus 2. So again, the bases are the same. Now I can set the exponents equal to each other. So this is 2 times 2x, 4x equals, now be careful here, this is 3 times x plus 2. So 4x equals 3x plus 6. Make sure you distribute to both. A lot of you forget this second one right here. Subtract 3x. So x equals 6, and we're done. All right, number 3. We have 8 and 32. So we already used 2 to the third as 8, so I'm thinking that we're going to go back to our 2's here. 2 to the third equals 8, and 2 to the fifth equals 32. So we're going to change both sides of this equation like we did on number 2. So 2 to the third is 8, and I leave the x minus 2. And 2 to the fifth is 32, and I leave the x plus 2. So the bases are the same. Cross them out. set this one equal to this one. So this becomes 3 times x minus 2 equals 5 times x plus 2. So let's distribute on both sides. 3x minus 6 equals 5x plus 10. So let's solve for x. I'm going to subtract the 3x over. So negative 6 equals 2x plus 10. And I'm going to subtract the 10 over. Come over here. So negative 16 equals 2x. Divide by 2. X equals negative 8. All right, number 4. So we have a fraction here. So hopefully when you see a fraction, you remember that you're going to have a negative exponent. Okay, so if I take this 1/4 and I'm going to bring this 4 up to the top, it's going to become 4 to the negative 1 x equals 8 to the x minus 1. Now, I'm going to go ahead and simplify this part right here so that we're not confused later on. So we have a 4 to the negative 1x equals 8 to the x minus 1. Okay, so we have to say we have a 4 and an 8. How can I make those bases the same? Well, I can go to my list that I made here. And I know 2 squared is 4 and 2 cubed is 8. So I'm going to change the left side to 2 squared and the right side to 2 to the third. So this becomes 2 squared negative 1x equals 2 to the third x minus 1. So the bases are the same. This becomes negative 2x equals 3 times x minus 1. So distribute the 3. Negative 2x equals 3x minus 3. So I'm going to subtract the 3x to the left. Negative 5x equals negative 3. Divide by negative 5. X equals 3/5. All right, number 5. A toy helicopter is ascending according to the formula y equals 2 to the x minus 5. Y is the height and x is the time. After how many seconds will the helicopter reach a height of 27 feet? Okay, so the height is 27 and they told us the height is y. So we're going to plug in 27. So they want us to solve for x. So let's get this by itself first. Let's add 5 over. So 27 plus 5 is 32. Now, even though there's not an exponent over here, we did one with the 32 earlier. 32 is 2 to the 5th. Bases are the same. X equals 5. We'll say 5 seconds. Okay, so on the front side, we were able to do the same, each side with the same base. On this side, though, we're not going to be able to do that. So we've got things like 5 and 12, and I can't make those have the same base. So what we're going to do is use logarithms, and we're going to use our power property. So before we even start, let's look at our power property real quick. If we had something like log x to the third, I could move this 3 in front of the log, and it became 3 log x. So what's going to happen now is instead of like log x cubed, we're going to have something like log 3 to the x. And I need to get this x out of the exponent. So in order to do that, I'm going to move the x in front, and now I have x times log 3. So this is going to give us the ability to solve for x. So on number 1, we have 5 to what power equals 12. Now, if you look back to this, what I did here, and I have the x on the exponent, notice if I don't have the log there, I can't do this. So how do I get the log here? Well, what you're going to do is literally put log on both sides. So if this thing is by itself, I'm going to take the log of both sides. So I'm going to write log 5 to the x equals log 12. So just like in any equation, like if I had 2x equals 5. If I do something to one side of the equation, I have to do it to the other because they're equal to each other. It's like a scale and they're balancing. So if I could add 3 here, I have to add 3 here. So same thing here. If you put a log on one side, you have to put a log on the other. And this is what people forget. They'll put a log on this side and they forget the one on this side. So now that I have a log on both sides, I'm going to use the power property and I can bring this x in front of the log. So now I have x log 5 equals log 12. So this is just saying x times log 5. Log 5 is just some number. It's being multiplied by here, by the x. So I can divide the whole thing, log 5. So log 5 crosses out, so x is by itself. And now I just put that in my calculator. Log 12 divided by log 5, 1.544. So up here it says give the solution in calculator ready form and in decimal places, 3 decimal places. So here's our 3 decimal places. Calculator ready form means what did you put in the calculator? So we would say x equals log 12 divided by log 5. That's what that means. Okay, so number 2. I'm going to do the same thing. I have the exponent by itself. So I'm going to take the log of both sides and I'm going to bring this thing in front here. So negative x log 6 equals log 10. So I have, this is being multiplied by log 6. So I'm going to do the same thing I did on the other one, divide by log 6. But I need to get rid of this negative 1 here. So I'm also going to do a negative 1 here. Because these 3 things are being multiplied, so I can go ahead and get rid of them all at once. So the negative 1 crosses out and the log 6 crosses out. So our calculator ready form would be log 10 divided by negative 1 log 6. And I'm going to put that in my calculator. Log 10 divided by, now you have to put an open parentheses here, and then your negative 1 log 6. So negative 1.285. All right, number 3. So I have the exponent by itself. So I'm going to take log of both sides. And I'm going to move this whole thing in front. So when I bring that in front, since I'm adding and subtracting now, I'm going to put that in parentheses. So x minus 2, then I have log 5 equals log 200. So how would I get rid of this log 5? Well, think about what it's doing here. It's being multiplied, so that means I'm going to divide by log 5. So now I have x minus 2. I'm going to keep that whole thing for a second. And how would you solve for x? You would add the 2 over, and then the 2 is gone. So if I was doing the calculator ready form, I would leave it like this. Log 200 divided by log 5 plus 2. And then let's put that in our calculator. So I'm going to do it 2 different steps. Log 200 divided by log 5 equals, and then I'm going to add 2 to that. So x equals 5.292. Okay, number 4. Let's take the log of both sides. So log 12 to the 2x equals log 1,000. Bring that 2x in front. So 2x log 12 equals log 1,000. So I have 3 things being multiplied here. 2 times x times log 12. So kind of like that negative 1 on the number 2, divide by, I'm going to divide by the log 12, but since this is being multiplied, I can divide by that as well. So over here, I'm going to divide by 2 log 12. So the 2's cancel, log 12's cancel. So calculator ready form would be x equals log 1000 divided by 2 log 12. But in your calculator, you have to be careful. Make sure, again, log 1000 divided by parentheses 2 log 12. So x equals 1.389. That would round up, but you can leave it like that. Okay, so my video is running out of time for some reason, so I'm not going to do both of these, but I want to talk about what you would do first. On this one, you would have to add the 5 over before you do the log of both sides. So that would become 11. No, sorry. 8 plus 5 would be 13. There we go. And on this one, this 5 is being multiplied. I would divide by the 5. So 8 to the 3x minus 2 equals 3. Now I would take the log of both sides. So log 3, 2x plus 1 equals log 13. This whole thing moves in front. 2x plus 1 log 3 equals log 13. Now on this one, you have to be careful here. You've got multiple things happening in front. So the first thing I would do is divide by log 3. So now you have 2x plus 1 equals this whole ugly thing, log 13 divided by log 3. So then to solve for x, I would have to subtract 1 and divide by 2. So check my hard copy of my notes so that you can see what all I've done there, because my video is about to cut me off.